assignment with you. Let's see how you did. Hopefully you guys did okay with this. All right, number 1 told us to circle the monomials, so that's what I did. These both only have one part, so those are the monomials. Number 2, I told you not to stress about ascending order because we typically never write anything in ascending order, so hopefully you figured it out. If I wanted ascending order for y, I wanted the exponents to increase as the problem went. So here you can see the exponents increase for the y's. Here the exponent increases. Here the exponent increases for the y's. So these are called ascending order, but we typically want answers in descending. Okay, it said to put a box around the trinomials. This is a trinomial. It's got 3 parts. This is a trinomial. It's got 3 parts. It said to put a 2 in front of the second degree polynomials. So this is degree 2, this one's degree 2, and this one's degree 2. And what are those called again if the highest exponent is degree 2? Quadratic. Okay, and then the expression that has the 0 degree is our constant. There's no variable at all, so there is no degree. There's 0 degree. Okay, these wanted us to put our powers of x in descending order. So that means you start with the highest exponent and go to lowest. I told you that when there's a mixture of x's and y's, there really isn't a proper order for how to write it. But since the directions said to put the powers of x in descending order, that's what I did. I started with the highest exponent on the x, and I went to the lowest exponent on the x, which is a 1. So I went from an exponent of a 5 to a 2 to a 1. So just following what those directions said to do there. So descending order, that's typically how we write our answers, highest exponent to lowest. Okay, this was a review problem. It asked us what the sum of these integers were. So remember, sum means add them all together. So that's what I did. I added the x to the x plus 1 to the x plus 2, combined like terms, and got 3x plus 3. Number 9. We had a question like this on the review for the last test that you guys took. So it talks about what the area is, it asks what the length is, and it gave us the width. So I wrote the formula for area of a rectangle. Area is length times width. I plugged the area into the A. I plugged the width into the W. I kept the L because that's what I'm trying to find. And then I get rid of multiplication by dividing. So I divide both sides by what's smushed against the L. And that way, 6 divided by 6 is 1. Shoop. A squared divided by A squared is 1. Shoop. B cubed divided by B cubed is 1. Shoop. C divided by C is 1. Shoop. All I'm left with is L. Over here, I had to review my rules of dividing exponents, or dividing the same base. So I started with the coefficients, 66 divided by 6, which is 11. When you divide the same base, you subtract the exponents. 3 minus 2 is 1. When I divide the b's, I subtract the exponents. 5 minus 3 is 2. And when I divide my c's, I subtract the exponents. 7 minus 1 is 6. So that was a review of our last section. Okay, just going to let you look at these. Number 10, the parentheses meant nothing, so I just combined my like terms. On 13, I had to distribute this negative. And so after I distributed the negative, then I combined my like terms. And I did write my answer in descending order, highest exponent to lowest. Okay, 11 and 14. 11, the parentheses mean nothing because there's nothing to distribute, so I just started combining my like terms. This one, I don't really care what order you have the answer in, as long as you have the negative with the 4x squared somewhere, you have the positive 4 with the xy somewhere, and you have a positive 6 with the y squared. Number 14, I did need to distribute this negative, so I did that first. I dropped whatever was down in the first set of parentheses, and then I started combining like terms. I combined the x squareds, then the x's, then the constants. And this one I did put my answer in descending order, highest exponent to lowest. Hopefully the adding and the subtracting isn't too bad. So if there's something to distribute, make sure you distribute before you do anything else. And then add and subtract like pieces. Okay, number 12. I did not need these parentheses for any reason. There was nothing to distribute, so I just started combining my x squareds, then I combined the constants. On number 15, I did have to distribute this negative, which gave me a positive 2x squared and a positive 6. I dropped whatever was in the first set of parentheses, and then I combined my x squareds and I combined my constants. And then just remember that whenever you add and subtract, you never change the exponents. If it starts in x squared, it ends in x squared. The only time we change exponents is if we multiply or divide. Okay, ready to go to the next page? I hope so. If not, you can pause me. Okay, this one. It gave us two sides of the triangle. I'm going to have to shrink this down just a tad. It gave us two sides of the triangle. It gave us the perimeter and wanted to know what the third side was. I decided to call the third side T. So I know with the triangle you find perimeter by adding the three sides. This side plus this side plus this side. So that's what I did. I added the bottom piece to this right side piece to this piece that I don't know, which I called T, and I set that equal to the perimeter that they gave me. So perimeter of a triangle is this side plus this side plus this side. Then I started combining like terms. I combined the 3x with the 3x and got 6x. I combined the 6 with the negative 5 and got 1. I know if I want to get t by itself, I need to get rid of all of this. And so I get rid of all of that by either adding or subtracting. And what I do to one side, I have to do to the other. And I did get rid of more than one thing at one time. And this is my final answer. And I know you could have done a lot of this just by adding these in your head and subtracting them from perimeter in your head. I am just trying to show it all to you in writing, so maybe you can follow along. So I just added this plus this plus this, set it equal to perimeter, combined the like terms that I had, and then to get t by itself I subtracted everything that was on the side with it. Okay, number 17. This is kind of like a problem that we had in the notes. We want to know what the area of the shaded region is if we have the total region and the unshaded. So remember, I find the area of the whole of the shaded region by finding the area of the whole total and subtracting this piece that wasn't shaded. And remember, in order to subtract the piece that wasn't shaded, in order to subtract all of it, you have to put parentheses around what you want to subtract, since there's more than one thing back here. And then you'll have to distribute that negative. So I took the total area that they gave me and I subtracted the unshaded, but remember that negative has to get distributed, and then I combined my like terms. I'll give you a moment to look at that. Okay, this one. They wanted to know the total area of the figure. So this is the area of the whole middle section, and these are the areas of those four corners. So if I want to know the total area, I take this area and I add it to this one, plus this one, plus this one, plus this one, and that plus that plus that plus that made this 4y squared back here. So I just add this area to these areas, and then I combine my like terms and got the 5y squared there in the back. So that problem was easy. If I just want to find the total area, I just add the area of all the separate rectangles. Okay, 20. This was like that one up above. He wanted to know the area of the shaded. If the area of the total is this, So in order to find the area of the shaded, I found the area of the whole thing, which is what they gave me, and then I subtract away these two areas added together. And remember, because I'm trying to subtract more than one thing, I have to put parentheses around everything I'm trying to subtract here, and then I'll end up distributing that negative. And once I do that, I combine like terms, and I'll get my final answer. Okay, I need everybody to make sure that your name is on this worksheet. Gather them into one pile. If you're in groups, if you guys happen to be in rows, then just pass them all the way up to the front of the rows. These need to get turned in, so make sure your name is on it, and then make sure that they get turned in. So next we're going to move on to the notes for the day, and I'll talk to you soon about that. Thank you.